Hey guys, all right, so this is section 1.6, and we want to look at other types of equations, kind of a review of the other ones we've covered in our intermediate algebra. So, the first equation I want to talk about is a rational equation. And this is an equation that has a rational expression for one or more terms. Basically, it's an equation that has a fraction or multiple fractions, is what you need to know. Now, a little word of caution with these. You must check that your solutions to these rational equations aren't extraneous. Okay? Specifically, we want to make sure when they're plugged into the original equation, they don't cause division by zero. So for example, if your equation has something like 1 over x in it, and we get an answer of x equals 0, then that would cause division by 0, so we have to cut out those values. You don't necessarily have to check through the whole problem, although that's a good idea on a test, like you do with some other types of extraneous cases, but you do want to make sure you're not causing that division by 0. Okay? So let's start with this first example. We have 4x plus 3 divided by 4 minus 2x over x plus 1 is equal to x. Okay? So the first thing we want to do, okay, probably the easiest way to solve these is to eliminate the fractions. To do that, I need to know what the LCD is, because if I multiply both sides of the equation by the LCD, then I simplify, it will eliminate all my fractions. So hopefully you're familiar with your LCD. In this case, it's 4 times x plus 1. Okay? So I don't want to multiply it out because then it's going to be harder to simplify. Remember, when we're going to simplify fractions, we want to get things fully factored out so then we can cancel things, right? If things are being multiplied, we can make cancellations. So what I'm going to do is I'm going to multiply the left-hand side of the equation by my LCD. And notice that I am writing it over 1 just because that helps some students remember that, oh yeah, the bottom doesn't get multiplied by this. So I'll do that probably here for the first 1 or 2 of these. And that's going to go to the whole side, so it's kind of like a distributive property. Like I said, I'm not going to actually multiply it out yet. I'll do the same thing to the right-hand side of the equation. So this is times 4 times x plus 1. So if I do this, what I'm going to get is I'm going to get 4 times x plus 1 times 4x plus 3 all over 4. That's our first distribution here. Next, we have minus 4 times x plus 1 times 2x over x plus 1. That's the second distribution. Next, we have 4x squared plus 4x over on the right-hand side. So notice what happens. Since everything is being multiplied up top here, I can cancel my 4's. Same thing here, I can cancel x plus 1's as the factors. So what am I left with? Well, now that I'm at this point, I can see that I'm going to have, it looks like a quadratic equation. That means I should probably start multiplying things out. So I have x plus 1 times 4x plus 3, meaning I have 4x squared plus 3x plus 4x, that's from the outer and inner. So we get 7x plus 3 minus, it looks like I'm left with 8x here is equal to 4x squared plus 4x. So I'm here right now, voila, no more fractions. Okay, so let's combine any like terms on each side, and it looks like we have 4x squared minus x plus 3 is equal to 4x squared plus 4x. Now we know with quadratic equations, we want to try to get everything on the same side and then equal to 0. So let's subtract 4x squared from both sides, and then we'll also subtract 4x from both sides. And now our quadratic equation is actually turning into a linear equation, which is pretty nice. Negative 5x plus 3 is equal to 0, meaning negative 5x equals negative 3, or x equals 3 over 5. Okay? And now I'm going to check if I put in 3/5 into the original equation, does it cause division by 0? It looks like I'm good. So this is my solution. So I have 3/5. I want to do one more, and that's b here. 3 over x minus 2 plus 1 over x plus 2 equals 12 over x squared minus 4. Now, before I look for an LCD, we always want to multiply. We always want to fully factor everything, right? So what I'm going to do is I'm going to take 3 over x minus 2 plus 1 over x plus 2, and I'm going to factor this second one, right? Remember, whenever we have a number, when we're trying to find LCDs, remember we usually try to factor them, right, when we used prime factorization. So I'm going to do the same thing with this polynomial. So this is x plus 2 and x minus 2. From here, I'm looking for an LCD, okay? So let's find a factor. I see an x minus 2, okay? So where does x minus 2 appear the most? Well, this is x minus 2 to the first power. This is x minus 2 to the first power. Well, I guess my LCD is just x minus 2, at least for that part. Now that I've taken care of all the x minus 2's, how about for the x plus 2's? X plus 2 to the first power. There's my LCD. So I'm going to do the same sort of thing. I'm going to multiply both sides of the equation by that LCD. And notice what's happening on the right-hand side. Canceling. On the left-hand side, x plus 2, x minus 2. Remember, it is technically over 1. I have 3 times x plus 2 times x minus 2 over x minus 2 plus x plus 2 times x minus 2 over x plus 2 is equal to 12. Okay? X plus 2's cancel, x minus 2's cancel. I'm left with 3x plus 6 plus x minus 2 equals 12. This is a simple linear equation. 4x plus 4 equals 12. 4x is equal to 8. X is equal to 2. So that's what I think the solution is. However, if I take that answer and plug it in up here, does that cause division by 0? Well, yeah, it does here and it does here. 2 minus 2 is 0. Meaning I have to go down here. I need to throw this answer away. It's extraneous. And I'm not left with any answer. So what do? I say either no solution, or I can write the empty set. All right.